Hi students, we are going to move into another chapter, colloids. So here in this chapter you have to learn what is colloids and different types of colloids and classification and preparation of these colloids and its properties and purification and different properties like optical, electrical, and at last different types of colloid salts, emulsion, gel, everything. So first of all, we are going to look on what is colloids. Colloids is a substance that is microscopically dispersed throughout any other substance. The word colloid that is came from Greek, the word kolla, that means glue. So colloids, we can say that it is just like a glue-like substance. So these are microscopically dispersed throughout another substance. This particle pass through a filter paper but not through a semi-permeable membrane. These are the properties of these colloids. And these colloids can be made settle by the process of centrifugation. And so what is meant by colloids? That having two phases. Colloidal solution means it is a heterogeneous system that consists of two phases. First phase is dispersed phase or a discontinuous phase, and a dispersion medium, that is a continuous phase. The dispersed phase particle, that is so this colloidal solution contains two phases. One is dispersed medium, where the substance is dispersed, and the substance which is going to disperse is the dispersed phase. So that will be a discontinuous phase. A dispersion medium will be a continuous phase. The dispersed phase particle have a diameter of between approximately 1 nanometer to 100 nanometer. Such particles, because it is in the range of 1 nanometer to 100 nanometer, so it is normally invisible in an optical, though the presence can be confirmed with the use of ultra microscope or electron microscope. We can't see the particle as our eyes as such, so it can be confirm the presence of such a particle through ultra microscope or an electron microscope. So we know different types of solution. So we have to identify this colloidal solution from other true solution or any other suspension. So what is mean by true solution? It is a particles of solute and a makeup of a particle or a solute into a solvent, that is a true solution, where the solvent particle of the solution is usually liquid but can be usually it will be a liquid or sometimes it will be a gas. So particle that is dispersed will be particles are atoms or ions or molecule that are very small in diameter. Then what do you mean by this true solution will be like this. Too much small particle will be there in a solution. Then what is suspension? Made up of a particle that is dispersed in a solvent and that particle are larger than those found in a solution. We can see that particle size by our eyes itself. So this particle in a suspension can be distributed throughout the suspension evenly by shaking the mixture. This is the suspension. So what is meant by colloid? It will be the size will be in between these two. That means it will not be very much large or it will not be very much small, or intermediate in size. That is a colloid. So that size we have discussed here. It is in between 1 to 100 nanometer. These are the example for the salt solution. It is the example for the true solution. Suspension. It is the floor suspended in water. That means some any powder, നമ്മളിപ്പോ എന്തെങ്കിലും powder dissolve ചെയ്യിച്ചു കഴിഞ്ഞാൽ എങ്ങനെ ഉണ്ടാവും. That is the suspension. കൊളോയിഡിന്റെ ഏറ്റവും വലിയ എക്സാമ്പിൾ നമുക്ക് പറയാൻ പറ്റുന്നതാണ് മിൽക്ക്. മിൽക്ക് ഈസ് എൻ ഇമൽസിഫൈഡ് കൊളോയിഡ് ആണ്. കൊളോയിഡിന്റെ ക്ലാസിഫിക്കേഷനിൽ വരുന്ന സംഭവമാണ് ഇമൽഷൻ എന്ന് പറയുന്നത്. അതാണ് മിൽക്ക് എന്ന് പറയുന്നത്. നെക്സ്റ്റ് വി ആർ ഗോയിങ് ടു look on the classification of colloidal system. The classification, first one is, before going to the classification of this colloid system, we can just look on the what is the difference between true solution, colloid solution and suspension. It is the difference in particle size and appearance. We can see true solution is clear and it is cloudy, and suspension also cloudy. Homogeneous ആയിരിക്കും. True solution colloidal എന്തായിരിക്കും homogeneous or heterogeneous ആയിരിക്കും. Suspension it will be heterogeneous. Transparent ആയിരിക്കും. പിന്നെ ഇതെന്താണ് often എന്താണ് opaque ആണ്. പിന്നെ ഇതാണ് എന്താണ് often opaque but can be transparent. Separation, it cannot be separated. It can be separated. Suspension it can be separated, or sometime after keeping some time that particle will settle out. That is the suspension. Filterability is passes through a filter paper. True, passes through the filter. Colloid also passes through the filter paper, but suspension means particle will not passes through the filter paper. These are the colloids examples, some jam or something. These are the examples. Smoke, etc. are the example for the colloids. And next we are going to look on the classification of colloids. It is based upon, first classification is based on the state of aggregation of two phases. That is the physical state of dispersed phase and a dispersion medium. Based on the nature of, next separation means based on the nature of interaction between dispersed phase and dispersion medium. Next one is based on a molecular size in the dispersed phase, based on appearance of colloids, based on electric charge on the dispersion phase. So first we are going to look on the based on physical state of dispersed phase and dispersion medium. Classification based on state of aggregation of two phases. So the dispersed phase, dispersion medium, then the colloidal system name and its example. Dispersion phase is solid and medium is solid, then it can be said that solid salt. Example is alloy, cranberry glass, etc. Dispersed phase solid and dispersion medium liquid mean it can be called as salt. Ink, blood is the example for salt. Dispersion phase solid and dispersion medium gas, we can say it as a aerosol. This the example for aerosol is smoke or ice cloud. A dispersion phase liquid, solid, gel. This you can see these are the different types of classification of this colloid system. Next classification is based on the affinity between these two phases. So that classification is two type, lyophilic and lyophobic classification. That dispersed phase and dispersion mediums interaction. And based upon the interaction between this dispersed phase and dispersion medium, it is two type, lyophilic and lyophobic. What is meant by lyophilic colloids? Colloidal solution in which dispersed phase has a great affinity for the dispersion. Colloidal solution in which dispersed phase has a great affinity towards the dispersion. Nalla attraction undava. There are also termed as an intrinsic colloids. Such substance have tendency to pass into colloidal solution when brought in contact with a dispersed medium. So, അങ്ങനത്തെ സബ്സ്റ്റൻസിൽ പെട്ടെന്ന് colloidal solution form ചെയ്യാനുള്ള കഴിവ് കൂടുതലായിരിക്കും. So, if the dispersed medium is water, they are called hydrophilic or emulsoid. So, dispersion medium, അപ്പോൾ അത്രയും attractive ആയിട്ടുള്ള dispersion mediumത്തിന് നമുക്ക് അന്നേരം എന്ത് പറയാൻ പറ്റും? If it is a water, then we can say it as hydrophilic or emulsoid. Lyophilic colloids are generally self-stabilized ആണ്. അത് പിന്നെ അതിന്റെ പാർട്ടിക്കിൾ പെട്ടെന്ന് അഗ്രിഗേറ്റ് ചെയ്ത് സെറ്റിൽ ചെയ്യുകയോ ഒന്നും ചെയ്യൂല. സോ ദാറ്റ് ആർ സെൽഫ് stabilized and reversible in nature and are heavily hydrated. Reversible nature എന്ന് പറഞ്ഞാൽ കൊളോയിഡൽ സൊല്യൂഷൻ അഥവാ ഇനി എന്തെങ്കിലും കാരണം കൊണ്ട് സെറ്റിൽ ചെയ്താൽ അത് പെട്ടെന്ന് തന്നെ എന്ത് ചെയ്യും, റിവേഴ്സ് ചെയ്ത് പിന്നെയും കൊളോയിഡ്സ് ആയിട്ട് മാറും. ഹെവിലി ഹൈഡ്രേറ്റഡ് ആണ്. എക്സാമ്പിൾസ് ഫോർ ദിസ് ലയോഫിലിക് കൊളോയിഡ്സ് ആർ സ്റ്റാർച്ച്, gelatin, rubber, protein are the example for the hydrophilic colloids, lyophilic colloids. And next, lyophobic colloids. Colloid solution in which the dispersed phase has no affinity to the dispersion medium. The interaction between the dispersion medium and dispersed phase is very less in the case of lyophobic colloids. So they are called extrinsic colloids. Such substance, the substance has no tendency to form that colloidal solution if they are in a contact with each other. So this type of colloids are known as lyophobic colloids, and that will be relatively unstable ആയിരിക്കും. കാരണം പെട്ടെന്നുള്ള ഒരു ഡിസ്റ്റർബൻസ് കൊണ്ട് തന്നെ അതെന്തായിട്ട് മാറും, ആ ഒരു കൊളോയിഡൽ നാച്ചറിന് that will change. അപ്പോൾ sometime that particle will get settled. They are irreversible ആയിരിക്കും. ഒരിക്കൽ സെറ്റിൽ ചെയ്ത് നമുക്ക് പിന്നെ തിരിച്ചത് കൊളോയിഡൽ പാർട്ടിക്കിൾ ആക്കിയിട്ട് തന്നെ മാറ്റാനുള്ള chance will be very less. So, and are stabilized by adding some more or small amount of electrolyte. These type of lyophobic colloids can be stabilized by adding some small amount of electrolyte. They are poorly hydrated and the lyophobic colloids dispersed medium is water and we can say it as a hydrophobic or suspenoids. Example for this type of colloids are gold, silver, salts of metal hydroxides, salts of metals like gold or silver, or salts of metal hydroxides, or salts of metal sulfide. എന്താണ് സോള് എന്നുള്ളത് നമ്മൾ പറഞ്ഞിട്ടുണ്ടല്ലേ. എന്നാൽ സോളിഡ് ഡിസ്പേഴ്സ്ഡ് ഫേസ് സോളിഡും ഡിസ്പേഴ്സ്ഡ് മീഡിയം ലിക്വിഡ് ആവുന്ന അവസ്ഥയാണ് സോള് എന്ന് പറയുന്നത് നമ്മൾ കണ്ടിട്ടുള്ളത്. അപ്പോൾ ദാറ്റ് ടൈപ്പ് ഓഫ് സോള്, ഈ സ്പെഷ്യൽ ടൈപ്പ് ഓഫ് സോളിനെല്ലാം എന്താണ്, ദാറ്റ് ഈസ് ദ എക്സാമ്പിൾ ഫോർ ലയോഫോബിക് കൊളോയിഡ്സിന് ഉദാഹരണം ആണ്. നെക്സ്റ്റ് ക്ലാസിഫിക്കേഷൻ ഈസ് based upon molecular size in the dispersed phase. Next is the classification is based on the molecular size in the dispersed phase. So first one is multimolecular colloids. In their individual particles of the dispersed phase consist of aggregates of atoms or small molecules having the diameter less than 10⁻⁷ centimeter. That particles are held by weak van der Waals forces. And next one is the macromolecular colloids. Here the particle size of this dispersed phase are sufficiently large in size enough to be colloidal solution called natural polymers. It is the example for the macromolecular colloids. And next one is the macromolecular or multimolecular colloids, and next one is the associated colloids. What is associated colloids? These colloids behave as a normal electrolyte at low concentration but behave as a colloids at a higher concentration. These associated colloids are also referred to as a micelle. These are the example for associated colloid is a micelle. It is termed as a micelle. That means it will be lower concentration and that will act as a normal electrolyte. Some higher concentration it will become as a colloid higher concentration. Sodium stearate behave as a electrolyte in a dilute solution but colloid in a higher concentration. That is the example. The example for this type of associated colloids are soaps, higher alkyl sulfonates, polyethylene oxides, etc. So next we are going to look on these how this soap works. It is the associated colloids or termed as a micelle. So next we are going to look on how does the soap works. Now thank you.